Welcome back, YouTubers. In this 8th episode of Java Programming Tutorials for Beginners, we're going to be talking about while loops. You would use while loops pretty much under similar circumstances when you'd use for loops. The only exception is that for loops usually have an incrementing counter associated with them, where while loops don't necessarily have to have that counter. However, any place where you use a for loop, you could actually replace that for loop with a while loop. So let's go over the syntax for a while loop. It's pretty easy. The keyword in Java is while, and then an open and close parentheses followed by curly brackets or braces. In the parentheses, all you need is a Boolean expression, and what will happen is whenever the Boolean expression resolves to true, then the code block specified by your curly braces will execute. And upon termination of that code block, it'll go back up to the top of the while loop and evaluate that Boolean expression again. If the expression is still true, the code block will execute again. This will repeat until the Boolean expression within the parentheses evaluates to false, and when that happens, the code block will not be executed and your program will go past the while loop and continue on. So let's go ahead and put a system.out.println here at the end to show that our program will be ending. And then within the while loop, let's just go ahead and set this to true. And we'll leave it like that, except Java knows that there will be an error here. So let's see what that error is. Unreachable code. So we'll uncomment this, and let's go ahead and just try running this just for fun. What I want you all to see is that this program will never ever end. And so we'll also see what happens when this occurs within the Eclipse IDE. So click run. You'll notice that your machine may start to slow down, and that's because this while loop is just repeating over and over and over and over again. And no code is actually getting executed since there's nothing in here. However, this Boolean expression is constantly being evaluated, and it always evaluates to true, but it's still going to eat up processing speed on your computer. And you can tell the program is still running and hasn't stopped because of this button right here. And the only way to actually quit this program is going to be to click the terminate button. So that was a bad example of how to use a while loop. Let's come up with a better one. Let's say we want to do a simple counter. Let's make an integer variable called counter, set it equal to 0, and let's just say we want the code block to execute while the counter is less than 10. And every time, let's go ahead and print out the counter. We'll say counter is equal to, and then we'll display what the value of the counter variable is. Let's go ahead and run that. Oh dear. You can see that it's just constantly printing out counter equals 0 and doing nothing else, and the program is never ending. So let's go ahead and click terminate, and that's because we didn't actually do anything to influence when this Boolean expression will become false. So there are a couple ways to do this. This is going to be very, very similar to a for loop, but let's go ahead and just add +1 to counter each time the for loop iterates. And so what you'll see here is we'll basically see 0 through 9 the same way we would for a for loop. And that is indeed what we see. Okay, so that's basically the syntax of a while loop. It's very simple, just that Boolean expression, and then you're free to do whatever you want inside that code block. Let's go ahead and do our demo. So here I have basically a task to do. We want to write a method that determines how many times a specified number can be multiplied by itself before that value exceeds a second specified number. Okay, so let's go ahead and erase all of our code, and let's start writing this method. The method is going to return an integer value, because it's going to tell us the number of times that the number was allowed to be multiplied by itself. So that's a public static, and then the return value is of type int. And let's just call this demo. And then let's call the first parameter the number that, and that this is the number that will be multiplied by itself. Let's call it the multiplier. And then the second parameter, let's call it the total, because that's the total number that we cannot exceed. Let's go back up to our main function and just go ahead and call this method, and we're going to print out the result. And let's come up with some numbers that we know how to work with. So 2 is a good one, and let's say 4. And so we know that, or not 4, let's say 16, and we know that 2 to the 4th is actually 16, so 2 times 2 times 2 times 2 is 16. So if you think about how many times 2 can be multiplied by itself, 2 times 2 is once, times 2 again is twice, times 2 again is 3. So for this example, we would expect the number 3 to come back. Alright, so in our method that we're implementing, let's go ahead and make a counter, because we're going to be counting how many times we multiply our number by ourselves. And let's go ahead and do another parameter called calculated total. We're going to set that to be equal to 0. No, it needs to be set to be equal to multiplier. And then we're going to do our while loop. We want to know while our calculated total is less than or equal to our total. Note that I said less than or equal to because we want to know when we exceed. It's okay if we're equal to the second number. And so then every time we're in the for loop, we basically want to take the calculated total and multiply the previously calculated total by the multiplier. And since we set the initial calculated total to be equal to the multiplier, this will work out so that the first time through, you're really just doing the multiplier times itself. And then after that, we need to update, this should not say method, that should say counter, because that's our counter. We're going to update our counter, which we're just going to add 1 to it. I haven't shown you guys this yet, but plus plus is basically another way of saying counter is equal to counter plus 1. And so that's essentially what that line of code does. It's just an abbreviation instead of having to type out the entire thing. And then lastly, when this calculation is all done, we want to return what the counter was. And that's it. So let's go ahead and run it. And remember that we said our call here should return the value 3. Let's go ahead and run it. And it returns 4. So something is going on here that is wrong. And so an easy way to debug code like this is to just go ahead and write a whole bunch of printout statements. So let's go ahead and say every time this while loop executes, we want to know what our counter was. So let's go ahead and print that out in a printout statement. And then let's also figure out what our calculated total was. And this is a good debugging technique, printing out your variable values as you're doing things. And so when you run this, the S was not capitalized there, and capitalization does matter. So let's run this and see what we get. So here's exactly what's happening within our while loop. The first time our let's run it again because I didn't format it correctly. Okay, the first time our counter is 1 and the calculated total is 4. And let's actually go ahead and do a system.out.println at the beginning of this demo called with, well, actually let's do it the way we would call it normally. So demo, and then we passed it the multiplier, comma, and then the next parameter was the total. And then say was called. Let's go ahead and save that. And fix our bug there. I accidentally mistyped. There's a underscore right there that needs to be removed. Let's go ahead and save it and run it again, make our output a little bit more clear. So we see that hello world was called first, of course, because that was our first system.out. And then our next system.out.println was demo of 2 and 16. And then we run through our for loop. So the first iteration counter was set to 1, calculated total was set to 4. Our second iteration counter was set to 2, and our calculated total was set to 8. Our third iteration, our counter was set to 3, and our calculated total was set to 16. And notice that our calculated total is now equal to the total that was passed in. So our real answer is 3. But because we have less than or equal to here, it's going to continue on one additional time because these two are equal. And so it goes around again, and we found out, or the next iteration, that our counter is set to 4, and our calculated total is way higher than 16. And so really the answer we want is 3. And so what we should, and the reason why this for loop continued is because this value isn't checked until after the calculated total has been, the multiplication has happened one additional time, and our counter has been, added or incremented one additional time. So that means before we return, we actually need to decrement our counter by 1. And so surprise, surprise, there's another shortcut, and this is effectively equal to counter is equal to counter minus 1. Again, it's just shorthand. You can think of it as that. So let's go ahead and run our program. And there we go. Our value that we returned was 3. And so this is looking like it's working. Now what we can do is we can go back and actually comment out all of our print lines. Save it, run it, and there we go. Let's go ahead and do one more quick example. Let's go ahead and do system.out.println, and let's stick with our powers of 2 theme. Except this time let's just say the total is 100. We know that 2 to the 6th power is 64 from our previous example, which means that 2 to the 7th is 128. So 2 can be multiplied by itself 6 times, I think, before the value exceeds 100. So let's go ahead and try that. No, that's not true. It's the number of multiplications that are happening isn't actually 6, it's actually 5, right? Because 2 times 2 is 2 to the 2nd, but that's only one. That's actually only one multiplication. So since 2 to the 7th is 128, we'd expect the answer to come back as 6. But it's really going to be 5 because there's only 5 multiplications. And sure enough, that is exactly what we see. So we know that when you do 2 to the 6th, that's 5 multiplications. When you do 2 to the 7th, that's 6 multiplications. Now, because 2 to the 6th is equal to 64, the 5 multiplications, the 5 is the number we want, and sure enough, that's what we get. So this has been another Java programming tutorial for beginners. I hope you have enjoyed this episode. If you have any questions, please leave them in the comment section below.